Hey, what's up guys? So here I am starting Sathish from SJBIT. So this is the video which is going to be the most important video for you guys for if you compare with any other videos, because in this video I'm going to cover all the basics which you need to know for to learn the software programs. So here we just start up with initially we are going to write the programs like codes. For storing data, we are going to have some separate location, and the code which you are going to write for that also we have some separate locations. So let us see now. Initially we have in the processor we have 4 kinds of locations, that is DS data segment, SS stack segment, CS code segment, ES extra segment. So these are like, in practically if you say means it's a shelf like, okay. And in order to, so let us assume a shelf like, okay, in your cupboard or anything, so that is equal to these segments, and your hand you are going to pick up the required stuff what you want, right? So that is that hand, if we are considering it as index registers. So in order to pick up anything from the data segment, we are going to use the index registers as SI, that is source index. For stack segment we are going to use stack pointer and base pointer, and for code segment we are going to use instruction pointer, and for extra segment we are going to use destination index. Okay guys, so these are the stack segments which you are going to use for writing the codes. And data segment will store data. If there is excess of data, so that will be stored in extra segment, and stack segment will store the subprograms, and code segment will store the instructions. So next we are going to move to the program will be starting by dot model anything. So usually we will use small, because small indicates that we are going to use 2 segments. Usually it will be dot data segment and dot code segment. If you write tiny, there is also tiny option is there. If you use tiny means then you can use only 1 segment. Obviously it's going to be the code segment, okay, or it can be data. It depends on the program what you write. So next thing what we are going to see is about the procedure. So I think you guys know about procedure and macro. If you guys don't know, you will be knowing on the programs during the time of explanation. So while writing the procedure, we will write procedure proc or any name of the disk or something, disk proc, and we can write here as near or far or short. This 3 indicates the range of values which you are going to use inside the procedure. So if you write short means the range will be like minus 127 to plus 128. After that far will be representing like plus or minus 2 GB space. Near means it will represent plus or minus 32 kilobytes, right? So we have covered 3 stuff right till now. So guys, listen carefully, otherwise you will guys mess up during the time of knowing the program. So next we will go to, we have finished 1, 2, 3, right? So initially next we will go to 4th one. So 4th one, what I am going to let you know guys is, for declaring a variable you will write under dot data, right? Okay, you will write under dot data. So you will initialize something like CR something. So for that you will write DB or DW, that is defined byte, and this is defined word. Defined byte indicates you can store values, each value will be stored up to 8 bits, and defined word will be storing of 16 bits. That is in location, in processor location, each location will have 88 bits. So if you use data byte, so each location will have new values. In defined word, every 2 locations will contain new values. That is, in defined word means 1, 2 will be there, but in defined word 0001, 0002. So new values will start in even numbers, and in data byte it will start in each and every locations. Then we can discuss about CR, that is carriage return. For carriage return, that is enter key will the ASCII code is 13 for in machine language coded it is 13, and for line fill, that is next line, for giving one single line, for that we are going to use the number as 10. Or for carriage return you can write it as ODH, because sometimes you need to compare whether you have pressed enter or not. For that we will compare with 0DH also. So next part we will go to excuse me 1 second. Yeah, now if you check it for any string which you are going to place it on the processor, so what happens here is, every time if you declare one something like str db and high, like that, if you press means, so in the processor it will store it up like hi, after that it will leave one location, next location will have the dollar symbol. So this part is much important, because if you check it out in Palindrome program, I have made a mistake, I have taken it here itself, so the whole calculation would have gone wrong. So you guys take it as leave one location and start with here and do the analysis, and you will get the answer right. Okay, so and in the explanation of Palindrome also I have left one instruction, that is decrement something. So you guys sit and analyze it and you will get same stuff what I have done, but I have left this instruction, and you guys can consider this instructions also, and you guys perform the operation and you will get the exact answer whatever is there in the program. So that is one correction I need to make it, so I'm telling it in basic itself. And then we are going to learn about push and pop. Okay, so initially if you can check it up here, is initially would have written AX value will be of 5 and BX value would have been of 6. Okay, after that what happens, you will push it up AX value, it will go to stack. After that it will go, you will push BX value, it will go to stack. So what happens after that, whatever corrections you made, like you will change it, the AX value will be 2 and BX value will be like 4, whatever code after you write, it will be like temporary value. After then when you pop again, the AX value won't be the same as what you have changed it, instead it will take the value from the stack segment itself. So after you write the pop BX and pop AX, the AX value will be changed to 5 again and BX value will be changed to 6 again. It won't be the same as the values which have changed before. So that the one thing you guys may be confused, so I'll let you know guys by this video itself. After then we'll go to addressing modes, different types of addressing mode. So listen up carefully. Direct addressing mode means what we do here is move AX, 100. So if you write within bracket means that represents that you are giving the address and you want to fetch the information from that address. So in the memory location, in the 100th location, if that contains A, so that A will be stored in AX register. So here you are giving directly the value of the address. So this is called direct addressing mode. What is indirect means, if you are writing like SI, AX, move means, so you are giving the value of SI. SI would have stored up something like 100, and that 100 value will be given to will be pushed here, will be seen here, and that value will be fetched, and that is moved to AX. That is indirectly you are specifying the value. So that is what we call as indirect addressing mode. And immediate addressing mode means, for example, move AX, 100 means that you are initializing the value, not the address. You are initializing the value to the AX value. So AX would have become 100, and then 1 second guys, I'll be back. So back again. So if the AX value will be moved, will be initialized to 100, not like A. So in this case, if you check means AX value will be turned to 100. So that is immediate addressing mode. After that, register to register addressing mode means the movement of data will be takes place within registers itself. So this is also one register and this is also one register. So BX value will be moved to AX. So that is called register addressing mode, because you are using only registers to transfer the data. And then relative addressing mode. Relative addressing mode means, now this is the memory location, and data is here as 10, 20, 30 and 50. Now this is initialized as something like array. Okay, so relative addressing mode means, now SI will be pointing here. Let us assume that SI is pointing here, and you want this 20 location to move to AX. So what you will write is AX SI plus 1 2, right? So SI 1 2 address, you want to, this address is stored here, and plus 2 means it will go to next second location, and that value will be moved to AX. So you are giving this program counter. That is what we call as relative addressing mode. So these are the basic addressing modes you need to know about. After that, auto increment, auto decrement is that you guys, I assume that you guys know about it. After then we will move to instructions, different types of instructions. So I think you guys will be knowing about move instruction. After that, compare. Compare means you will write CMP, you will write AX comma BX means my AX value will be separated by BX. So if it is 0, then it is equal. If it is not, that is not equal. So depends on that, we'll usually give the jump instructions. So I'll tell you later. So exchange, EXCHG, this is exchange, that is AX comma BX means DX value will be moved to AX and AX value will be moved to BX. That is what exchange instruction does. And increment, AX means AX will be incremented by 1, and then decrement AX means AX value will be decremented by 1. After that, loop instruction works mainly on CX register. So if CX register is equal to 5 value, so loop instruction can be executed till 5 times. When it is CX becomes 0, loop instruction won't get executed. So that's what we usually say, that CX register will be used for counting purpose. So that's the loop instruction is all about. After that, jump instruction. So every time if you see, like if you're comparing anything, okay, compare AX comma BX and jump 0 to something exit. Okay, so every time the jump instruction, the value will be checked with this destination value, not the source value. Every time it will check the destination value and then it will execute accordingly. So if it is 0, this will get executed. If it is not, it will go to the next instruction. So this jump instruction doesn't matter with the CX register. It's just if you write jump to something, it will jump without seeing any condition or anything. So that is where we use jump. And we have some conditional jumps also. I'll tell you now. So you guys take it down in a paper or whatever. I'll detect it. You guys can understand by the way what I'm saying itself. Okay, right? So JA is jump if above. That is, if it is higher, if you take this example, if AX is higher, then it will jump, otherwise it won't jump. So jump if above and jump if not below or equal. So both are kind of same only. After that, jump if above or equal, jump if not below, jump if no carry. If carry flag is nothing is there, that is it's not a 0, then it will jump. Got it? So jump if below. Afterwards, jump if not above or equal, jump no carry, jump if carry is there, that is if carry flag is equal to 1, then it will jump. So here if carry flag is equal to 0, then it will jump. Next, jump if below or equal. Next, jump if not above. Next, jump if equal, jump if 0, jump if greater, jump if not lesser than or equal to, jump if greater than or equal to, jump if not lesser than. Next, jump if lesser. Next, jump if not greater than or equal to. Next, final is jump if Cx is equal to 0. Right? If you write JZ also, it doesn't matter. But if you want to check for Cx value exactly, so you can write jump if Cx is equal to 0. So if Cx is equal to 0, then it will jump. So that's the conditional jumps that I've written. So let's go for next stuff. Okay, add. So add means add ax comma bx means bx value and ax value and bx value will be added, and the result will be stored in ax, and bx value remains the same. And XOR usually used for clearing the contents of anything. If you want to make ax register to 0, sorry for the delay. So if you want to make ax value is equal to 0, so you will write XOR ax comma ax. So that comes like if XOR means same value means it is equal to 0, right? So therefore x will become equal to 0 now. So that's the XOR value XOR instruction does. So afterwards we'll go to CLD. That is, CLD means clear direction flag, that you guys know about it. Then we'll go to interrupts. So there are interrupts that you guys need to know. That is move AH comma 09H. It displays the whole string till it encounters a dollar symbol. Then 01H to get input from the user, a single character input from the user, and 02H to display a single character to the output screen. 0AH to get an input of string of characters, sequence of characters, and 4CH means to terminate the process, to terminate the program. After the 2CH means it get the current system time from the computer. After that 08H in 21H means it waits till you give any input. If it waits till you press any key. After that 3CH means it creates a file, and 41H means it deletes a file. So this works under in 21H. So in 21H means it is a DOS interrupt. So we can see as in 21H or there, in 16H is there, in 10H is there. So these are DOS interrupt which I have discussed here fully. And in 16H is keyboard interrupt, and in 10H is video interrupt. So if you want to create one blank screen to display anything, so you will use this in 10H. Then what else? I think it's all done now. Yeah, one more thing we have forgotten. So there are two kind of instructions is there, AAM, AAD. So ASCII adjust after multiplication, ASCII adjust after division. So what we do here is, in ASCII adjust after multiplication, we are going to unpack the AL value to AX. So consider AL is equal to like 75. So what we are going to do is 75 will be divided by 10, and what is the remainder if you check? 75. So 7 will be moved to AH and 5 will be moved to AL. That is, AX value will become now 0705. So this is the AX value. This is what we use for AAM. So if you can see here, the photo for multiplication and division of ASCII numbers requires that the numbers first be converted into unpacked BCD format. So after multiplication, if you see AAM performs the following operations: divides AL value by 10, stores quotient in AH, stores remainder in AL. So that's the stuff. And for next is AAD. So in this, what happens here is AX will be packed to AL. So take an example, AX is equal to something like 0705. Okay, I'll take the same stuff. AX is currently 0705. So what happens here is, if you execute this instruction, it will happen AH into 10 plus AL. So if you see here, AH is 707, AL is 05. So AH into 10 is 7 into 10 is 70 plus AL, that is 5, which is equal to 75, and this is stored in AL. So as you can see, the AL contains 75 now, and that is what we called as packing of elements. So if you see the photo here which I am showing you right now, AAD allows for a 2-byte dividend in AX. The divisor can be only a single byte. So it performs what is AAD multiplies the AH by 10, then adds a product to AL and clears the AH. So AH value will be moved to 00 after the AAD occurs. After the AAD, division is performed. So that is the 2 instructions you guys need to know for the software program. So I think I've completed almost all the basics. So you guys, I think you guys be able to understand the following programs. So please understand and let me know the feedback. Thank you. Bye bye.